Hi, everyone. Thanks for joining us today for this edition of the Mobius webinar series, The Science of the Grind. My name's AJ, and today I'm joined by two experts in the field of cannabis analytics and processing. I'm joined by Dr. Marcus Rogan and Trevor Cross. Thanks for being here, Marcus and Trevor. We have Marcus and Trevor with us for the next hour, and following the main presentation, there'll be an opportunity to address your questions. So throughout the presentation today, please feel free to use the Q&A function on the webinar to pose questions. We've got a team in behind the scenes here who's kind of triaging those questions, and we'll make sure that we get to those in more depth at the end of the presentation and see what kind of topics are of the most interest to everyone. So before we get started here, I thought that I would take a moment to just discuss why we should care about this topic. So essentially, you can grow the best flower on the planet, but if you're not processing it correctly, the consumer experience can be negatively impacted. So for example, pre-rolls that are packed inconsistently or incorrectly will not produce the ideal smoke. And extract products that are manufactured using inferior equipment or starting material that's incorrectly prepared will not result in the highest quality end product. The potency of the flower and preservation of cannabinoids is directly related to how the material is prepared and processed through the manufacturing steps. So ultimately, this all ties back to the quality of the final end product that the consumer is purchasing and the profit potential associated with that product. What our guests today have found through their research and experience is that the preparation of the plant material is just as important as the quality of the plant material itself. And that's what we're going to explore today. So I'm going to turn things over first to Dr. Marcus Rogan. So Dr. Rogan brings scientific and leadership experience to the cannabis industry, both from an academic background in organic chemistry and industry experience in crop protection, plant analytics, and pharmaceutical manufacturing. Dr. Rogan oversaw multiple teams focused on the whole processing flow of cannabis production, from harvest and drying through processing and extraction, all the way to formulation and quality control and analytics. Dr. Rogan has also completed research in cannabis milling and analyzing particle size and potency for various applications like joints and pre-rolls. So with that, Marcus, I'd like to turn it over to you to talk about some of your research and your findings.
Thank you very much for having me, and thank you very much to the audience for listening in. So today we will basically talk about grinding and how that affects a few processes in the cannabis industry and hemp, as it turns out. So on the next slide, we are controlled chemistry. That's a research laboratory located on the University of British Columbia in Vancouver campus. And we do all the weird and wonderful chemistry research of cannabis and hemp. And we do it here in Canada because in Canada it's legal. So I have a federal license to do the work, and I don't have the FDA rating me. And so as we do the different research projects, or have all these chemistry interests, we come up like, what can we do? There are students around. What interesting research can we come up with? So how we think on the next slide. So how we think about research is these rapture quadrants. It's like the Pasteur quadrant, but for cannabis. And so on the next slide, you see the idea is that you can organize your research either by increasing fundamental knowledge or by having immediate application. And we all might like to tinker around, but at some point it has to give us anything. So today I want to talk about some fundamental research and some applied fundamental research that we have done. And so the first project on the next slide is so we had a mill, or we had actually quite a few mills in the laboratory standing around. And the question was, is basically the first step of chemical analysis of cannabis and hemp, does that already influence the analysis itself? So the milling. So the project was, on the next slide, defined as, oh, sorry, I don't have a perfect memory of all the slides. So basically there are different milling methods. There are different milling techniques, milling approaches, hammer mills, blades, burrs, and so on. So ask experts like Mobius or other manufacturers like what those mills are, but basically it's either cutting, squeezing, or breaking stuff. And you want to get to a smaller particle size. But does that actually influence your analytics? So when we defined the project on the next slide, we wanted to know, does milling have an influence on the cannabinoid recovery? Because cannabis producers care about the THC number. And if milling, the first step in analysis, already plays a part in that number, then we should actually care about it. And then secondly, as a testing lab, you need to test as much as possible to get back the capital investment of your instruments. So if the sample preparation is a bottleneck and you can't get it onto the machine, then you're wasting potential income streams. And then our goal was basically we want to figure out, can you optimize cost, throughput, and maybe even reduce contamination, because these pesky pesticides like to stick in any nook and crannies of your milling instrumentation and might cross-contaminate. And so when we then started the research, on the next slide, we grabbed a few mills we had. We had a coffee grinder, I guess the OG of cannabis sample preparation in testing laboratories. And we had a souped up food processor, so to say, which has a large vessel and blade mill. But we also had these special single-use containers. So there's a picture on the bottom left. That is like a plastic two-piece thing where you can put your cannabis in, it mills, and then you can throw away these containers. So to prevent any possible cross-contamination. So you don't have to waste time on cleaning and actually use up lots of solvents, which is a waste, and the time required to clean. So like, and now that we have different mill machines, and then we use different milling parameters, and we want to see, do they change our results? So on the next slide, I present the results for THC flower or THCA-rich flower. We also did it for hemp or CBDA-rich flower. But here, this is for THCA-rich flower. And we found that within the error bars, all the results are about the same. So it doesn't really matter which mill you use, you get about the same number out. But for single-use containers and pulsed coffee grinder, you get a ever so slightly higher THCA and THC number out. So there might be something, like if you just can move it by like 0.2, 0.3 of a percent point of the reported THC number, that is worth actually quite a lot of money. So, but if you mill, I heard that from some people, do you destroy your cannabis? So that was then what we looked at as well in the next slides. So first, do we see decarboxylation? No, we don't really see decarboxylation. There is no apparent difference in the THCA to THC ratio in these different milling methods. And the next question would be, is there CBN produced? And again, we don't really see any CBN production based on the milling. We just had flower maybe a little too long in our safe from harvest, so there was a bit of a base concentration in it. So then in summary, we can say on the next slide, so we can basically say it doesn't really matter how you mill it. But if you go for like the smallest, minutest improvement of your process, a single-use container gets you a little bit higher THCA and THC numbers, and the same holds true for CBDA and CBD. And when I talk to some testing laboratories, actually the cost of cleaning is a substantial part. Like it's a bottleneck for them to clean their mills. So if you can remove that cost through single-use containers, that might, in your particular case, be efficient or beneficial. And also, there is no chance of cross-contamination if you're using a new milling vessel every single time. So there's a bit we can do. And so, but you didn't care about the analytical lab. You care about how does it affect your joints. So on the next slide, this is a applied fundamental question of joints, or applied fundamental, like we learn something, but we directly can use it. So if we mill our joint, does it make our joint better or worse? And why do I care about joints? Because on the next slide, you see this graph that shows you the sales fraction of products here in Canada, and it is the same holds true for the US, or the trends are the same, is that cannabis flower is taking up a smaller percentage of the customer basket. But they're not substituting with vapes or edibles. They're substituting it with flower pre-rolled in a joint, because right, they buy flower to roll a joint, so they might as well buy the joint. So if the consumer wants the pre-roll, the manufacturer should make the pre-roll. The manufacturer probably doesn't use a hand grinder and then rolls every joint individually and package it. They want to scale this up. And if we scale it up, can we optimize this? So therefore, we want to look at it. But I'm like a stereotype. I'm German. I'm teaching chemistry, and I'm all about process optimization. I don't really understand the connoisseur cannabis, but I have a machine that can give me the numbers. So on the next slide, I have some videos of Carl, our cannabis aerosol research laboratory, where we pre-program puff profiles and can either test vape cartridges or joints. If we start the second video, right, there's a joint that gets smoked, and then we capture what comes off. On the next slide, we have some pictures for that. We capture what comes off a joint or a vape cartridge on a filter pad so that we can quantify cannabinoids per puff, or we do it in an impinger to capture more volatile compounds like terpenes and toxicants so that we can talk about the flavor. And students were very excited to smoke lots of joints. They were very disappointed when they realized it wasn't them. But still, we smoked a lot of joints. So on the next slide, I have a table. Oh, wait. See, I don't remember all the stuff by hand. So first off, joints are really bad from a architecture standpoint. Like cigarettes are well designed and lots of money has been put into them. I'm not judging if they are a good thing. I'm just judging that they are made well. From an architecture standpoint and science standpoint. But cannabis joints are not. So there's this paper out of Israel, like one of the papers I would have liked to do is when you smoke a joint, at the beginning you inhale less THC per puff than at the end of your joint. So while you like a fresh joint, that's because of the terpenes that come off at the beginning. But the crotch, like the last little bit of the cannabis joint, that has all the THC coming off. So there's a difference in cannabinoid delivery. So it's not really a good medical product. But nevertheless, that inspired us. What could influence how much THC comes off? So therefore, we designed a study where we looked at both THC, on the next slide, where we looked at THC cultivars and CBD cultivars, so cannabis and hemp, and we milled them to different particle sizes. So we had 1, 3, and 5 millimeter particle size. And we smoked the joint, and we wanted to know how does that behave in various categories, which I have like one big graph on the next slide. that we can quickly run through is, so lots of bar graphs. Sorry for that, but timing. So the group of bars on the left is the puff count. And the first 3 bars are for cannabis, for THC, and the next 3 bars are for CBD. And what you can see there is that the larger the particle size, so 5 millimeter being the largest, has more puffs to get through the joint. And this is nearly a doubling between 1 millimeter and 5 millimeter particle size. So it takes longer to smoke the same weight of cannabis if it's a larger particle. But like opposing to that, a small particle gives you more THC per puff. So if you want lots of THC quickly, more particle size. And then if you add everything together, a large particle size still gives you more THC overall because of more puffs. So if you want like all the THC, large particle size. And for CBD, weirdly enough, you inhale basically all the THC, all the CBD that's there. In THC, you only inhale about 40% of the THC that is in the flower of the joint. We don't know why that is the case yet, but that is in accordance with all the other research papers on that topic. So then we can summarize on the next slide. That basically says particle size really influences how you consume cannabis. A 1 millimeter particle size would be very good if you want loads of THC per puff. But if you want a longer lasting, maybe for sharing, larger particle size, burns longer, gives you more THC overall. We still have a problem that there's a variation from sample to sample. So they're not stable, they're not reproducible yet. So we still need to make the architecture better, that it's really bang on and we get the same thing every time. And there's way more CBD coming off a joint than there's THC, and that is still something we want to figure out in the future. So with that, I'm handing it over to Extraction.
Great. And I'll get to the technical questions towards the end here, but I do have one question around staffing. So even after you started to employ Carl the joint smoker, I imagine you're still a fairly popular scientist to work for, and you have no problem getting students to work for you?
Yeah, no, that's not a problem. They're still excited. And I don't tell everyone ahead of time that there isn't personal experience required.
Great. Thanks very much, Marcus. So we're going to hand things over to Trevor now, and he's going to speak on this topic from an extractor's perspective. So Trevor Cross has nearly a decade of experience managing and procuring equipment for extraction and analytical labs. He's procured equipment for some of the largest MSOs in the industry with particular expertise in supercritical CO2, alcohol, and hydrocarbon extraction processes. Trevor's built out multiple cannabis processing facilities performing extraction utilizing the most common solvents, distillation, and isolation. So Trevor, over to you.
Thank you, AJ. But yeah, no. What are the impacts of milling when it comes to extraction? Well, it's first good to ask what's the problem you're trying to solve for, because hemp and cannabis actually approach the question very differently. Starting with the hemp industry, the end goal is typically isolate. So why is that isolate? Because, well, it's close to 100% purity. And that allows you to make consistent SOP formulations. So when you're making tinctures, gummies, and things like that, then it just allows you to be sure that what you're putting in is consistent. If you were to go something, produce a product with distillate, for example, which would be considered a full spectrum product that includes the other minor cannabinoids, the actual percentage of CBD can have a wide range, somewhere between 80 to 95% typically. So starting from isolate, it ensures that the compounds that you're intending to put in are going to be the compounds in your final product. Another reason why isolate's so popular in the hemp industry is actually the derivative market that's kind of taken off. So if you've seen these things at gas stations or head shops, Delta 8, Delta 10, HHC, GHCP, stuff like that, those are actually semi-synthetic compounds coming from CBD. So what a chemist is doing is taking CBD and then changing that using reactions to those compounds. So if you're starting with isolate, which is closer to 100% CBD, then it assures that you're not producing any other compounds or unwanted compounds in your final product. So the preparation of cannabis material for the hemp industry is to capture the most CBD that you can from the plant, so that you can then further process it into isolate through distillation and isolation. The medical or recreational cannabis approaches it very differently, because their intention typically with the initial extraction is to make connoisseur products. So things like live resin, diamonds, shatter, crumble, all the cool, the fun extracts that you can find at a dispensary. Those are typically an initial extraction just done under certain conditions to make a visually appealing product. This market is very driven by the consumer. So every so often the flavor of the month will change and something more popular will arise. But they're typically being processed in a way to create that connoisseur product. And the preparation plays a major role in that. If you want to go to the next slide. So I'm going to start with CO2, which I have a lot of experience with, but maybe a little bit hard for people to understand. But I feel like it's a really great example of what of how preparation can affect your overall extraction. So supercritical CO2, you essentially have CO2 is essentially phasing back and forth between a liquid and a gas very quickly. I like to imagine the extraction column as almost like a river, pushing the cannabinoids down the extraction column to be captured. But if you look to the right, there's a graph there that shows that as you decrease, this is actually a graph from a paper I used a lot while setting up labs. Sorry, I'm finding where I am in my notes. But as you can see, from this graph, the smaller the particle size, the better extraction efficiency, or the more you're capturing, the smaller you grind your material. Now, this isn't a study done on cannabis, but it's just a guide that we used back when we were setting up labs and developing procedures to help guide us in the right direction. However, if you want to go to the next slide, this is also showing that when you grind your particles too fine, so this one's going to from 0.345 millimeters to 0.08, the extraction efficiency or the yield actually decreases. So at a certain point, although you can grind it finer, it actually decreases your efficiency because something called channeling occurs. Channeling is essentially where you're missing parts of the material you're intending to extract. So if we go back to our river example of the supercritical fluid pushing the cannabinoids down your extraction column, that river is always going to want to take the path of least resistance. So if you got finer particles that are packed tightly together, it's going to miss those compounds. So you're not going to be able to extract the most efficiently as you could, because it's consistently going in the path of least resistance and avoiding those compounds. So the grind size and how you pack your extraction column really affect the extraction efficiency or the quality of your product. This slide is going on to other extraction methods. Use the most common methods are alcohol and hydrocarbon. This is a little bit more easier for people to understand because this is a solid liquid extraction. Most people typically do a solid liquid extraction every morning when they make their cup of coffee. Instead of water and coffee, you're using cannabis and a non-polar solvent or a universal solvent. So since cannabis is non-polar, it's hydrophobic, so it doesn't like water. So that's why we use these solvents instead. Hydrocarbon is a strictly non-polar solvent, so it's really intended to, you know, capture cannabis and a few other fatty compounds in the plant. And then alcohol, however, is a more abrasive solvent. It's a universal solvent, so that's really pulling up a lot of material. You can see on the right, I have some examples of when I first started in the industry, but that black shatter was actually with hydrocarbon done at room temperature, and we found that we were utilizing a mill that just really milled things really too fine for our purposes, and so we kept getting these black slabs of shatter. Initially, we thought, oh no, we're gonna lose our jobs, but eventually we dialed it in and was able to get something a little bit more like what you see down in the bottom right. And the black shatter, you know, is still salvageable. We eventually developed our distillation procedures and utilized them for that. So, but both hydrocarbon and alcohol can be done at lower temperatures to mitigate the amount of additional materials that you're pulling up. If you want to go to the next slide. And this is a graph that was prepared by Mobius, but it really illustrates what I'm trying to convey in these slides. As you can see, for what I just touched on, larger particle sizes are needed for the ethanol extraction. You're working with a more abrasive solvent as compared to the hydrocarbon extraction, which you can grind finer. And then the fresh frozen, or that's kind of the more connoisseur market, and that's ground a little bit less because it's the intention is to make a more visually appealing product. If you want to go to the next slide. So next I have just some examples of material that we received here at Titan Processors. We get a wide range of things just because the hemp industry is so vast that a lot of materials, farmers handle their materials in different ways. I'm starting with the worst material that we've seen, but this was some material that was put through a screw press, and we were actually having to grind this and just wash it twice with our alcohol extractor to get the full amount of CBD we could from this material. So as you can see with that photo, those buds are really packed together. So because of that, what I was talking about earlier, channeling, that was occurring where the solvent couldn't reach all of the every part of the plant to capture the most cannabinoids we could from it. If you want to go to the next slide. This is a material that was ground a bit finer. This we only had to extract once, but after testing the material, we did show that there was, you know, a little bit of cannabinoids left on it. So because it's ground very fine, we are getting some channeling that is occurring. So it's not the best efficiency we could do, but that being said, it was better than the last. And then in addition, because it's ground so fine, since we're using alcohol, that abrasive solvent, we're picking up more parts from the plant and producing a much thicker oil, which I'll touch on here shortly. If you want to go to the next slide. And then this is some of the best material that we've seen. It was hang dried with minimal processing, and we were able to grind it to our specs. And when we did the extractions, you could actually see the color difference in our sight glasses. That last material, it was a very brown black liquid running through the system when it was solvent with our extractions in it, while this one was much more amber, nicer looking red. So this minimal processing thing was great for us, because then we could grind it to exactly how we needed to get the best extraction. And then if you want to go to the next slide, touching on what I was talking about with the finer processing, and apologies for the photos, I'm not the best photographer, but that bucket to the left is actually from the finer ground material that I was showing earlier, but that is a very thick oil. If you were to, turn that upside down at room temperature, it would almost want to stay in the bucket, almost like a Dairy Queen Blizzard. While on the right is something that we were able to grind to our specs, and this material was actually really nice to work with, because you could see it's already crystallizing as a crude oil. So because it's already crystallizing as a crude oil, that shows that the potency is quite high in the product, and that we have less undesirables in the plant, and that makes the whole process easier. So you go to the next slide. I have a comparison of the distillation. So as we're distilling the finer product, we don't get that clear kind of yellowy distillate that you can see on the right. That was the one on the right was done from the really good crude oil, while the one on the left was done from the thicker oil. And when you're in the distillation procedures, another thing about the thicker oil is that you can almost run it. It's almost harder to run, and you can run into more either system clogs if you're using a wiped film, or just you're not able to get everything you can because of the potency is not as high as it could be. And then if you want to go to the next slide, and then at the end of the day, if you're making isolate, isolate's almost a blank canvas because of its color and consistency. So any additional pigment picked up can really affect the overall quality of the isolate you're producing, because it's really shown at the end of the process. On the left, I have material from some distillate that was a little bit darker, that had to be milled. That's what is going on in that photo. Well, on the right is some really nice isolate that we were able to produce from a better quality distillate. And thank you for your time.
Yeah, no, thank you very much. I'm curious. I mean, we'll move into our Q&A here now. What are your thoughts, Trevor, just while we're on the subject here, about bubble hash and rosin versus solvent-based extraction?
Yeah, I mean, bubble hash and rosin, it's interesting because that's almost an OG extraction method that's becoming a lot more popular. I think that's the case because you really need a higher quality cannabis to create those products. That process is more mechanical and it is solvent based. So you're essentially putting your cannabis in these bubble hash bags, and then it's almost like a washing machine that you're utilizing at larger scales, and with that washing machine, with it, throwing the cannabis around in the bags, it's essentially a mechanical process getting the trichomes off the plant. So what you're doing is you're beating the trichomes off the plant and then collecting those. So it's a lot less efficient than a solvent-based extraction, but what I just said, it's a little bit more popular nowadays with the cannabis connoisseurs, because you really have to have good material going in to create it. So it just assures the consumer that they're buying the highest quality product.
Nice. Well then, so for you, what is your favorite either solvent to extract with, or perhaps it's even solventless?
Oh yeah. Uh, the honestly, my favorite has always been hydrocarbon to do, just because I do like carbon products products a lot, and I do like the variables that you can change with that process. But that being said, you know, there is a place for any solvent or solventless process in a lab.
So basically, would you, if you had a lab that was set up with everything imaginable, and I've been to a couple of larger like MSO style facilities where they have everything at their disposal, would you just take a look at the material you were dealing with and make a decision based on that? Or would you try and kind of force it knowing, hey, no, this is, we can make anything out of this starting product. So what is my, I don't know, best product for marketing right now, or what am I short on?
Um, I'm sorry, what was the question?
Well, if you had everything at your disposal, would you kind of, work through it, or would you make your decision based on what you had to work with? For example, I think about chefs, how they talk about they'll do their shopping at the market, and they a high-end chef will drive their menu based on what fresh products are available, whether it's produce or meat or seafood or something like that, and then frame the menu around that versus choosing the menu and forcing the ingredients. So would you let your product you're working with drive you, or just what you want to use as your solvent drive you?
Gotcha. Oh, I understand. Uh, I mean, I think a lot of this typically it's driven by the market. I think if I were to make a lab nowadays, I definitely include solventless, because that seems to be something that is included quite a lot. But yeah, it's important to have other aspects so you can get the most from your plants.
Yeah, understandable. Actually, Marcus, I wouldn't mind throwing that same question over to you. How much would you be driven by your starting material? Or is it all about, oh, because I'm really fascinated by this whole notion that, hey, let's make these joints out of the 5 millimeter particle versus these on the 1 or the 3. Does it matter what your input material is, or just you can grind any input material down to any size?
So in principle, you can mill down anything into any size. But then I would go back, what's the intended use? If we just in our minds develop a product here, a 1 millimeter particle size would be a fast burning, dual puff, higher potency per puff product. So that could be a dog walker. So that's something you want to consume fast. While a 5 millimeter particle or a larger particle size product might lend itself more as a session, a fireplace, or like an evening group shareable product. And my assumption would be that in a slow, longer session, you would want to savor and enjoy the product more than if you just want to quickly get high while you walk your dog. So if I have a flower with particularly high terpene numbers and a better aroma, that probably lends itself better as a shareable product to enjoy and savor. But if my flower is lower on the flavor, on the aroma, with lower numbers of terpenes or myrcene, then maybe that would be something I would put more into the category of 1 millimeter particles, so to quick consume and just get high off it.
Yeah.
So I would,
So,
yes, I use the quality to decide, but then it's not so much question which mill's better. It's more the question, what product do I want to get at the end?
yeah, so on that note, are you finding interest from manufacturers in marketing things that way? For example, would they be marketing them from a technical perspective where they're labeling by particle size, or are they marketing them based on usage? And is that even happening yet, or this is something that you anticipate happening? The dog walker
So
versus the campfire.
yeah, so I don't assume that ever the product will be labeled as 1 millimeter versus 5 millimeter. Too technical, customer doesn't care. Customer cares about outcome. So it would probably be labeled as the dog walker or the shareable, and you just have the milling technology underneath it for the producer to deal with. And when we look in the sales numbers of cannabis joints or pre-rolls, we see that the fastest growing subsection of pre-rolls are connoisseur slash blended or it's connoisseur or blended mixed strain products. It is actually that the single strain or the sativa or the indica joints are losing market share. So, and also another big winner in the cannabis pre-roll sector are infused pre-rolls. So if we think about it, the consumer buys less of single strain, but more of elevated product, better product. Right? Infusing it with oil doesn't make it better, but it gives the appearance of it better. So the consumer definitely wants a better experience. I don't think the consumer really knows what they want, nor does the industry actually put any effort into figuring it out. So that's what my lab is for. So call me. I think there's a lot we can still do to make better pre-rolls. And considering it is such a strong growing sector, there should be the interest and the disposable money for that. But I have seen less research in the field than I would like.
It'll be interesting to see if things go more in that direction. I always like to compare it to, say, the wine industry, just because the wine industry has been a legal industry for obviously a lot longer, and you can kind of see the trends there where you've got the connoisseur wanting to get very technical wine consumers versus people that just enjoy a glass of wine. They're not interested in learning too much technically about it, and where the marketing kind of goes with it. I enjoy my wine, and I see the labels on there that talk about the points, but I've never bothered getting into that. And so I sort of see that as some of the more technical stuff around the particle size here. So I had an interesting question come in here, and it's something that I wonder about in a lot of different contexts. Today, we're talking about this in the context of extraction and sort of this later downstream manufacturing. So the question we had was, in addition to parameters like particle size, this person has a number of clients who are looking for guidance on target water activity values throughout the manufacturing process. Could either of you comment on this? This might be more something that's applicable to Trevor's activities, but could you, Trevor, talk a little bit about water activity and how that impacts things through the manufacturing process?
Yeah, of course. No, water activity definitely affects the overall extraction efficiency. When I was doing a CO2 extraction, for example, we would always decarb the materials beforehand. Decarbing it, or having CBDA turn to CBD just makes the solvent more effective. And then in addition, since we're using temperature to decarb, it's also removing water. With CO2 extraction, you can actually have little ice particles forming, so that's blocking off what you can get fully from from your extraction. So it's really important to remove the water, not only for supercritical CO2, but also if you want to extract the most effectively using hydrocarbon, which is non-polar, so hydrophobic, so it doesn't like water, so it's not going to perform as well. That being said, there are products like all the live products, live resin, stuff like that, that actually have wet plant in it, and for that you're sacrificing the overall extraction efficiency to get a better product for the consumer. So it's got that more terpy taste to it, and additional processes can be done later to that extracted material to make sure you're getting everything from the plant. But the overall water activity greatly affects how well your extraction is doing.
There's a lot of factors to take into account here when you're doing your work. It's incredible.
I'm
Yeah.
I'm very sorry, Trevor.
Yeah.
So I'm a chemist. I do want to do a few corrections, if you don't mind. I just want to make sure that we're actually correct here. Supercritical CO2 is at 31 degrees Celsius or 70 Fahrenheit. No water crystals, ice crystals will ever form, right? We are way above, above room temperature, so there won't be any freezing. The problem with alcohol and CO2 extraction is that water becomes a cold solvent. So if you have water in your flour, you now have a CO2 water or ethanol water solvent mixture that now will extract or not extract cannabinoids, right? Water doesn't extract cannabinoids, so if you add water to one of those solvents, your solvent becomes less able to transport cannabinoids, therefore your extraction efficiency goes down. But they're not ice crystals. And then for hydrocarbon extraction, if water is there, it doesn't care, like does really not care. So it's there or not, the solvent doesn't even see it, doesn't really influence that much. But I just wanted the ice crystal correct.
Yeah, no worries.
So, I mean, we're getting into some of these very technical aspects here. So actually, Mark, so I'd like to ask you, you'd mentioned in your presentation that CBD is delivered more consistently than THC, but we don't quite know why yet. Do you have a hypothesis as to why that might be?
Yeah, so CO2, so CBD, CO2. CBD has basically effective full extraction efficiency in a pre-roll. So all the CBD that's in the hemp flower will end up in your mouth. While for THC, only 30 to 50% of the THC in the flower ends up in your mouth. Why that discrepancy is there, we do not know yet. We have a few ideas which we would want to research in the future. So for one, neither CBD or THC ever evaporates. Like they will not be a gas that you inhale. They will always stay solid phase, but they will be dissolved in oil droplets or some form of droplets that you inhale. So it's an aerosol, not a gas of cannabinoids you inhale. So the first idea we would have, or you would look at, is CBD better able to dissolve in those droplets you inhale? There is a solubility difference in solvents between alcohol, CBD and THC. There's a great paper by David Doughton on the question of chocolate analytics, where you can take the findings and translate that potentially to aerosols. Also, CBD is ever so slightly more water soluble than THC is. So maybe some humidity or water activity in the flower produces a more watery aerosol droplets, and those can pull along CBD. We actually have a study in the works right now where we look at water activity and the effect on hemp smoking. And the quantitative data from the smoke machine I should receive in the next few weeks, so we know more then.
Do you notice the same behavior or patterns with other cannabinoids, so with CBG or CBN?
We had not cultivars rich enough in those cannabinoids to see a signal that we could trust. So we haven't been able to see that yet.
Yeah, it'll be interesting to see if those gain in popularity and then what the research shows on those down the road.
But it should also, so CBG also has two phenol groups like CBD, so solubility should be more in that direction, while CBC again only has one phenol free like THC. So properly, if I think about it, I would categorize them CBC probably similar to THC, CBG similar to CBD.
Great. Okay. I know we're getting to the end of our time here. I had one very practical question come in here, and it's actually for you, Marcus. So you talked about how you can achieve a little bump in performance by not having to do the cleaning and having the disposable grinder vessels. Is there a specific company that makes these disposable vessels?
Yes, it's not Mobius.
Oh no, we don't manufacture that product, but yes, it's for a specific type of scientific grinder.
Yes, Fritsch, a German manufacturer, they make a grinder with an adapter to have then their plastic cups on top of that.
Gotcha. Yeah. So yeah, the Mobius mill, we do a perforated style mill. It was mentioned at the beginning, there's all the different style of mills, the knife mills, hammer mills. Mobius mills are rotor mill with the perforated screen underneath. If anybody who's on the this webinar is interested in learning more about comparing the different milling styles, you can go to mobiustrimmer.com and head under the resources section there for webinars. And in there, you will find a presentation on the different milling styles, and then you can find in there what will work best for what you're looking for. Unless there's anything else from Marcus and Trevor, I'm going to wrap things up there, and I'll just share on this last slide here contact information. We have recorded the session today, and this will be posted to the Mobius website. So again, mobiustrimmer.com. And I believe that everybody who's signed up for the webinar will be receiving a link to this as well. So I'd really like to thank everybody for joining us. Oh, I have one last minute question coming in here. So, and I've still got a couple of minutes here. So what would be the most optimal grind size for infused flower pre-rolls? So that one's over to you, Marcus. And actually, Trevor, you might have some thoughts on that one as well. So optimal grind size for infused flower pre-rolls.
So I don't have an answer yet. So the work I presented today was all student project after hours. As the client project to pay us money for the work, actually they go to the client and not into the public domain. So if you want to find out, we are the lab to figure it out for you. But so a few thoughts there. It is the grind side is the question of like stability of the joint, and then delivery basically being the media through which the air flows and brings all the aerosol to your mouth. So it's one. But then with infused joint, it becomes also the question of how do you fill a joint if you put oil on it? So do you pre-coat your particles and then fill it in the joint? Do you have like so? I think it will be mostly a manufacturing question. How can you get the infusion or the oil into the joint as well as the flower pipe? For one, and that's another research project, and that we already have data. If you infuse a joint, the joint burns really, really slow. You might recall we had 30 to 60 puffs for a half gram for a joint. If you infuse a joint, you are at 150 to 200 puffs. So they burn really, really slow. So do you then counteract that with small particle size of the flower to bring it back down to a reasonable level? Or do you hop on the wagon and really make a shareable product by having it now burn like 400 puffs by having larger particle size? So multivariate optimization problems, the problems I like.
Yeah, absolutely. That's really interesting. That's a massive difference there. 30 to 60 to, you know, up to 200, I think you just said there. So
Yeah.
that's quite a difference. Trevor, I mean, I know that this is not what you were kind of talking about today, more extraction, but any thoughts on infusions and things like that?
No, I mean, I've seen some cool equipment coming out on the market, you know, kind of trying to make that process easier. So it's been interesting to see what people have come up with. But that being said, no, nothing further from me on that topic.
Okay, great. Well, and I was kind of wrapping up, but one more thing that's, I don't know if either of you wants to comment on, maybe this is more Marcus, but obviously Mobius manufactures a couple of mills. We have a tabletop mill and we have a larger scale mill. And I would say that the most popular screens that we sell for grinding for pre-rolls would be either a 1.6 or a 2 millimeter rasp screen. So think kind of like a cheese grater. So it's shredding the buds as they go through. And then there's the 1/8 inch perforated screen. So think more like a hole punch where you're getting that, not really the shredding, but almost like it's just being pushed through there. Those tend to be the most popular. So Marcus, would you see any difference between using a perforated style screen versus shredding the product for the smokability and how it impacts the things that you discussed today?
I would assume so. We did look at packing density of joints, and that does change the airflow a bit. And if you think about your mill style, it's basically a change in packing density of the particle, right? You either rip it apart or you push it together to make it smaller. So I would assume that if you have them pushed together more, you probably capture or trap cannabinoids inside the flower particle that is not easily extracted. Because in a joint, you actually don't inhale the THC at the burn tip. The burn tip only produces hot air that then flows over the flower between the burn tip and your mouth, that then pulls off the THC from in between and brings to your mouth. So any part of the flower that can't get any airflow probably won't release any THC. So if it's pushed together and folded up on itself, it might trap it and you might never get that.
And that's along the same theme that Trevor was talking about, channeling and having particles that are compacted together, and whatever your extraction method is, not being able to access it. So
in principle, yes.
Yeah. Okay. Thank you for that. Okay, well, I'd like to thank everybody for attending today. Really appreciate it. Particularly appreciate Marcus and Trevor for taking the time to prepare with us and join us today and offer their expertise. We have the contact information for people up here. So if you want to get in touch with either of our speakers, they've let me know that they're okay with you emailing them. Those were real email addresses they gave us. So thanks very much. And for any more information on Mobius, please visit mobiustrimmer.com. Thanks a lot, everyone.
Thank you.
Thank you.